Hi, this is Hao Xiangfan from Sun University, co-authored with Guanzheng Chen, Dr. Xingbo Wang from Cornell University, and Zheng Huipeng from Sun University. I present Lesson Planner. A lesson plan is an instructor's roadmap of what students need to learn and how it will be done effectively during class time. An example lesson plan preparation process is shown at the left side. It integrates textbooks or online resources and also generative content nowadays in a strategical teaching flow. A lesson plan could be used as a reference for slides that present on classes or directly as instructional notes in classes. However, previous work indicates that there are some challenges in lesson planning for novice teachers. The first is they lack experience in delivering a course using effective strategies. Some traditional solution is using pedagogies in lesson planning, such as Bloom's taxonomy, Cope's learning cycle, and Garnett's 9 events, which we also use as the foundational theory in our system, and I will be introduce it further. The second challenge is the novice teacher face difficulties in curating relevant materials to execute the instructional activities. One possible solution is using large language model in lesson planning. However, there are also some challenges. For example, fragmented outputs are hard to organize and lack the experience to effectively prompt. The figure is a really complex prompt for generating suitable content. In summary, in order to alleviate this problem, we developed an interactive system, Lesson Planner, that leverages LLM-generated content to assist teachers in preparing pedagogy-driven lesson plans. We adopted a formative study to design and develop Lesson Planner, working with 6 teachers and teaching assistants. The first column is the Garnett's 9 events, such as gain attention, inform learners of objectives, and the second column is the activities participants mentioned in the co-design session. After considering how LLM can facilitate it and generalization of these activities, we implemented some of them into our system. For example, we implement post open-ended question or case studies in our system in the event gain attention. So after collecting, transcribe, recording, we process them by semantic analysis. There are 4 design goals: encourage effective teaching strategy, generate high-quality materials, offer preset prompts, and provide flexible user control. So here is the user flow of Lesson Planner. The user will first be directed to this page, the goal setting page. In this page, users are asked to input the metadata of the lesson, such as lesson name and the lesson topic and the student's knowledge stage. After that, it could be generate some lesson goals. However, this may not keep alignment to teachers' needs, so they is able to edit it. For example, removing or add more requirements and ask the LLM to refine it. They could push the button to ask LLM to regenerate based on their edition. After clicking generation button, users are directed to the lesson planning page. The system generates the outline based on the course objective and automatically split them into subsections. This is the overview of this page. There are blocks containing subsections in these pages. And in each block, there is a title, a control panel, and instructional events as hints, and a content area. After click the C1, will be turned to the editing mode. Here, user can edit and click E1 to open the Lesson Plan Assistant. Then the other panel on the right side will be appeared. It's the assistant. LessonPlanner-Assisting prepare preset actions when user click the buttons in the core action set or the contextual action set. We can see some general action are in the core action set, such as regenerate, and actions in the contextual action sets are the predefined activities within the selected instructional events based on the Garner's 9 event theory. User can edit the instructional event in each section if they want. They define what event should be integrated in this subsection. And LLM responses will be shown in the output text area. User could select, copy the content to the edit area of lesson plans. Also, they could further ask LLM for details if it's unsatisfied. So let's overview again this page. The left panel is for showing the generated content and for user editing. The right panel, called a system, is for detailed plans generation based on pedagogies. We also provide other functions for improving its usability, such as advanced markdown editor and history drawer. We then conduct a human rating user study to verify the lesson planner can help novice teacher in lesson planning. The baseline is set as Web ChatGPT and Google as search engine and a markdown editor. In each task, we encourage participants to design the lesson plan for assigned course topic in 40 minutes. After these 2 tasks, we have a final interview with them. We have 3 research questions in this user study: lesson planning outcome, lesson planning process, and perception of lesson planner. After that, we invited experts from different educational levels and subjects to further evaluate lesson planner. The research question is the same as the user study 1. Now I present some key findings. For lesson planning outcomes, most of the participants think that hints of Garner's 9 events in lesson planner can guide them to prepare a lesson plan with more effective teaching content. They think that the visible text helps them think and explore the possibility of conducting their class from various perspectives. However, 2 of the participants think that outcome may be less effective in specific subject domains. For example, one elementary teacher referred that it is quite different from the lesson plan they have read, and it would be less effective. For lesson planning process, some participants think that workload is mainly from selection of LLM's output, but sometimes this burden is beneficial because the system offers various content, and before they use this system, they could only stick to one basic idea. However, some participants think that workload are mainly from refinement and verification, and the system lack of knowledge, stage alignment, and accuracy. For perception of lesson planner, all of the users think that it promotes users' creativity. For example, a computer network teacher thinks the generated topic can be used in their class. And diverse attitude to the reliability of the lesson planner. One interesting finding is that participants who interact with LLMs daily or generally show a higher degree of trust in the system than those who use it less frequently. It indicates that the novice teacher may have an inappropriate trust within our system. Well, our evaluation with students and experts offer design consideration for supporting education activities with generative models. Our design considerations are based generated content on reliable knowledge database and allow flexible customization of prompt to LLMs. And it could integrate multimodal generated content in the system. There are much more future work we could do to apply generative model for lesson planning. For example, we could customize for experienced teacher, and the system could generate additional teaching materials such as slides or images, and we could do field research for evaluation with students' feedback. Okay, in summary, we present Lesson Planner and offer insights for applying generative models to educational domains. Thanks.
We have time for one question for Hao-Xiang. Hao-Xiang, I have a question for you. So one of the things that I sometimes think about as a teacher is economic planning of classes. So how can I make sure in the time budget that I have that I can put together a compelling class? And so I wondered if you've thought at all about how something like Lesson Planner could incorporate those types of kind of like non-functional aspects of a lesson plan, of like how much time do I have to prepare this, into kind of the elaborateness and the kinds of activities that are proposed.
Okay. That's a good question. So that's why our target user is set as the novice teacher, because an experienced teacher, he usually have their own idea to construct their own class. However, for a novice teacher, they don't think so much. They are only focused on how they can easily construct the basic classroom activities. So if the user want to add some, want to add some activities they really not integrated it in our system, it may be cost more time. So our future work, we think we are going to solve this problem and customize for experienced teacher. And for example, we can use the chain of thoughts technique to generate the activities that feature the class the teacher taught.
Thank you very much. And let's thank Hao-Xiang one more time.
Thank you.